Hello friend, the topic is product of vectors. Okay, that is the multiplication of vectors. It's not easy as the multiplication of a scalar because vector is related with direction and the multiplication of a direction is somewhat different things. It's not easy. So how it is done? Let's see. It has two types. One is called a scalar product and other is called vector product. One is called a scalar product and other is called vector product. Scalar product. If the product that is resultant is a scalar, then it is called a scalar product. It has also a name dot product and the representation is done in this way. If there are two vector A and B, A is a vector, B is a vector because an arrowhead sign has been put over his head, okay, and the product becomes AB cos theta. This is only magnitude, B magnitude, and this theta is the angle between A and B, okay. And if the product is vector, then the product will be called vector product, okay. And it has also some different name called cross product, and representation is done in this way. A cross B is equal to AB sin theta n hat. What is n hat? Is a unit vector and it has a direction perpendicular to the plane containing A and B. Suppose A and B, all these two vectors are lying on the plane of paper, then n vector will lie perpendicular to the plane of paper, okay. That is, the vector product will lie perpendicular to the plane containing A and B. Example, let's see first the example of scalar product. Scalar product example is work. Work is a scalar quantity, force is a vector quantity, and displacement is also a vector quantity, and it has been shown over here. F is a vector, S is a vector, and W is a scalar quantity, so no any arrow sign has been put over the W character, okay. Next, see the example of the vector product. Vector product has the example torque. Torque is a vector quantity. It is written like this one. Torque is equal to radius cross force. Radius into force. Radius is also a vector quantity. Force is also a vector quantity. Now next thing is that we have to find out the direction. Okay, we have to understand the direction, in which direction the vector product will be. Okay, let's see. If there are two vectors A and B and there is an angle between A and B theta, okay, and A and B, these two vectors are lying on a plane of paper, supposing, then the direction of vector product will be the direction of the advancement of the tip of the right-handed screw, which is rotated in the direction from A to B. If a right-handed screw is rotated in the direction from A to B, in this example it is rotated clockwise, then the advancement of the tip of the right-handed screw will give the direction of the vector product. Here in this example it will be downward, okay. Next things, A cross B cannot be equal to B cross A. Okay, A cross B cannot be equal to B cross A because A cross B has a direction, but B cross A will have a direction opposite to the A cross B. So it can be written like this one: A cross B is equal to minus B cross A. Next, I am providing a solution of a problem. Okay. This way it will clear your concept about the dot product. For what value of m will the vectors, this one and this one, be perpendicular to each other? Okay. If there are two vectors and they are perpendicular to each other, then their dot product must be 0. So here, if there are two vectors A dot B and if it is 0, then AB cos theta is also 0. A, B all becomes 0. All becomes actually all vanish if they are brought in the right side. Okay, So theta becomes, cos theta becomes 0, that is theta becomes pi by 2. So here the scalar product, that is dot product of this vector and this vector, must be equal to 0. During multiplication I will multiply the component of unit vector I with the component of unit vector I, okay, this one and this one, because the dissimilar unit vector, the dot product of dissimilar unit vector will give the 0 value, okay, just like it one I cap and j cap, the dot product of I and j cap, because I has a value 1, j has a value 1, but the angle between them is pi by 2, that is 90 degree, and cos pi by 2 is 0, so overall it becomes 0. That's why I have I'm just multiplying the component of I with only component of I of the other vectors, similarly j and similarly k. So I dot I, that means that I cap dot I cap becomes here like this one, the value of I is 1, the magnitude of j is 1, and the angle between them is cos 0 degree, cos 0 has a value 1, so it becomes 1. So this will be 1, this will be 1, and this will be 1, all things bracket in bracket will becomes 1. So the equation will becomes 6 minus 12 plus m is equal to 0, and on rearrangement we will find the value of m, that is equal to 6. Okay, this is a very important problem. Such type of problems are asked, and that's why I have shown it on my video. Thank you for watching it.